Okay, so this is another copper making iodine reacting with fire sulfate question. I've left off A because that goes into stuff we do in transition metals, which we haven't covered yet. So we'll leave that for now. Well, it's pretty simple, but there's a little bit about copper that perhaps you don't know yet. Okay, so first question is for step 1. You can see they made this copper methanoate compounds. And they did that by reacting a copper compound, not copper itself, but a copper compound with methanoic acid. So you can choose any copper compound, copper oxides, copper hydroxide. I chose copper carbonate, and it's got to be with methanoic acid. Remember about methanoate ions, these are 1-, that's 2+, so you need 2 of these, every one of those, and that obviously causes balancing over here as well. Then you got this again from Thompson step 3, so they added Ki, and the copper 2+ reacts with the iodide ions to make a precipitate of copper 1 iodide and iodine, so we're releasing the iodine again. Okay, end point of this one, you need starch, and the starch will go from blue-black to colourless stroke white. It'll be white because you have this white precipitate in this case, but you could just say colourless, that's fine. Okay, so now we've got to work out X. So from here, bits of information we need are the concentration and the volume of the sodium thiosulfate. So we use those to work out the number of moles of thiosulfate. If you know the moles of thiosulfate, we halve it to get the moles of iodine. If you know the moles of iodine, we double it to get the moles of copper. So we're back to the same number again. So that's the number of moles of copper in a 25 centimetre cubed sample that was taken. That's obviously 1/10 sample of the whole 250, so I times it by 10. So that gives me the moles of the copper 2+. If I know the moles of copper, I know the moles of all this, because there's 1 copper per formula. So I knew the mass of that compound. I got its moles, so mass over moles gives me molar mass. And then I can take away the mass of the bit that I know. I can work out from using the periodic table, 1 copper plus 2 hydrogens plus 2 carbons plus 4 oxygens. That all comes to 153.5. Take that away from the molar mass of the whole thing, leaves me 72. Divide that by the molar mass of water, and that gives me 4. So there's 4 waters. So this X, which I made a bit of a meal of there, that X is 4.